Proper service and repair procedures are vital to the safe, reliable operation of all motor vehicles, as well as the personal safety of those performing repairs. This video outlines procedures for servicing and repairing vehicles using safe, effective methods. Safety notes, cautions, and warnings should be followed, along with standard procedures to eliminate the possibility of personal injury or improper service, which could damage the vehicle or compromise its safety. It is important to note that repair procedures and techniques, tools and parts for servicing motor vehicles, as well as the skill and experience of the individual performing the work, vary widely. It is not possible to anticipate all of the conceivable ways or conditions under which vehicles may be serviced, or to provide cautions as to all possible hazards that may result. Standard and accepted safety precautions and equipment should be used when handling toxic or flammable fluids, and safety goggles or other protection should be used during cutting, grinding, chiseling, prying, or any other process that can cause material removal or projectiles. You should never wear overly loose clothing, neckties, or jewelry when servicing a vehicle. These can get caught in moving parts under the hood and cause serious injury. Some procedures require the use of tools specially designed for a specific purpose. Before substituting another tool or procedure, you must be completely satisfied that neither your personal safety nor the performance of the vehicle will be endangered. Although information in this video is based on industry sources and as complete as possible at the time of production, the possibility exists that some car manufacturers made later changes which could not be included here. While striving for total accuracy, AutoZone cannot assume responsibility for any errors, changes, or omissions that may occur in the compilation of this data. Special tools are recommended by the vehicle manufacturer to perform some specific jobs. The jobs contained in this video don't require any specialty tools that aren't readily available from AutoZone or other tool distributor. Refer to a service manual for specific diagnostic, repair, and tool information, including part numbers for specialty tools. Before substituting any tool for the one recommended, read the safety notice in the previous section. No part of this video may be reproduced or transmitted in any form or by any means, electronic or mechanical, including photocopying, recording, storage in an information retrieval system, or otherwise, without the written permission of the publisher. Any unauthorized commercial use, resale, or mailing list database development, utilization, or application is also prohibited.
Hi, I'm Bruce Bonebrake. Welcome to this installment of the AutoZone Do-It-Yourself video series. Chances are you've seen the check engine light come on while driving. Today we're going to explain why the light is so important and what it means when it comes on and how to diagnose the problem. Then we'll show you how to reset the light once the problem has been corrected. Today's vehicles have several types of indicator lights to warn the driver of problems. First are the typical warning lamps that have been used for decades to alert us of low oil pressure, engine temperature, and so on. Warning lights are usually red in color and report on only one specific component or condition. For instance, a brake light that comes on when we try to drive with the emergency brake set. The second type of indicator, known as a malfunction indicator light, and usually amber colored, lets us know when there's a problem within one of the systems monitored by the car's onboard diagnostic computer. The check engine light is one of these. It illuminates automatically whenever the computer detects possible trouble with the emission control system, fuel mixture, engine performance, electrical circuits, or drivetrain. The light coming on does not necessarily mean that you have a big expensive problem. Sometimes it can be as simple as a gas cap that has not been tightened properly. This is a good time to point out that not all cars have an indicator that says check engine. Your particular vehicle may have a service engine light, or it may have just an engine icon. No matter what type is on your car, when the light comes on, the vehicle should be checked for a cause of the problem as soon as possible by connecting a code reader, such as this one, to the vehicle to display the diagnostic trouble code stored in the system. Pay special attention to a check engine light that flashes while driving. A flashing indicator is alerting the driver to discontinue driving the vehicle as soon as possible because of a significant ongoing misfire. This can cause other systems to fail and possibly lead to expensive engine repairs if not addressed. You may be wondering why your vehicle needs a computer system and what it does exactly. Beginning in the early 1970s, car manufacturers were required to lower vehicle emissions. One of the first emissions devices was a positive crankcase ventilation, or PCV valve. Prior to the use of the PCV valve, vapors from the crankcase were simply released into the air. The PCV valve captures the vapors and reburns them in the combustion process. One of the next emission devices was the catalytic converter. The catalytic converter basically acts as a furnace to break down the pollutants created within the combustion process. By the late 70s, one of the first onboard computer systems was installed on select Chrysler vehicles. Other vehicle manufacturers soon followed. By the early 80s, the use of onboard computers to control the ignition spark timing and fuel mixture was becoming common. As emission laws got tougher throughout the 80s and early 90s, many different onboard computer systems were introduced by vehicle manufacturers. Unfortunately, most of these systems were manufacturer specific and in some cases vehicle specific. The complexity soon became expensive for the automotive repair industry. In the early 1990s, the EPA mandated that any vehicle sold within the United States must comply to a new standard called OBDII. It stands for Onboard Diagnostic System 2. All vehicles made during or after the model year 1996 have to comply to the OBDII standards. An engine management system such as OBDII can be divided into three main parts: the inputs, or sensors, the processing unit, or main computer, and the outputs, which are primarily fuel injectors, ignition coils, and transmission shift solenoids. The input sensors monitor a wide variety of conditions that could affect engine operation. The sensors feed this information via voltages and resistances to the main computer. The main computer is programmed to analyze all of these inputs simultaneously and make determinations on how to alter the fuel ratio and ignition timing of the engine, as well as when to shift the transmission to another gear. Let's talk about the critical conditions that input sensors need to monitor for proper engine operation. The first is throttle angle. Obviously, the computer needs to know how far the accelerator is being depressed by the driver. This will be a large determining factor in how much fuel the computer feeds the engine through the fuel injectors. The throttle positioning sensor is the sensor that monitors this. This sensor mounts on the side of the throttle plate on the engine. The next input is engine temperature. A cold engine needs more fuel to run than a warm engine does. Therefore, the system needs a way to monitor engine temperature. The coolant temperature sensor performs this job. It threads into the coolant jacket of the engine and constantly monitors engine temperature. The next input is air temperature. The air that is being taken into the engine can obviously vary greatly from winter to summer and region to region. Colder air needs more fuel to burn efficiently than does warmer air. So an air intake temperature sensor is used to monitor the temperature of incoming air. This sensor will be located somewhere in the air intake ducting or intake manifold. In addition to the temperature of the air entering the engine, the computer also needs to know how much air is getting to the engine. To operate efficiently, an engine must have the correct air-fuel ratio. This is typically 14 parts air to 1 part fuel. The way the engine management system knows the amount of air entering the engine is through what is called the mass airflow sensor. The sensor reports the amount of air entering the engine, and the computer will adjust the amount of fuel accordingly. Two more critical inputs are the position of the crankshaft and camshaft and their rotation. The computer needs to know the position of each so it can determine exactly when to fire the coil and fuel injector for each cylinder. There are trigger wheels attached to both the camshaft and crankshaft, and the sensors continuously read these trigger wheels to determine the exact location of the shafts in their rotation. Finally, there is a sensor that tells the computer how efficiently the engine is operating. Ideally, the system will deliver just the right amount of fuel and air to the engine and will burn all of the fuel and air completely. No fuel will be wasted. By having a sensor in the exhaust pipe, the computer can monitor if the engine is burning all the fuel-air mixture completely. The oxygen sensor performs this function and tells the computer if there's too much fuel or air in the mixture. The computer can adjust the amount of fuel up or down to correct. Now let's talk about the outputs of the system. First are the fuel injectors. The computer controls the injectors by opening and closing them hundreds of times per minute. The amount of time the injector is open is called the pulse width. The computer increases the amount of fuel entering the engine by extending the pulse width, meaning it holds the fuel injector open for a slightly longer period of time. It lowers the amount of fuel by decreasing the pulse width. Next are the ignition coils. The computer fires the ignition coil for each cylinder with precise timing. As engine operating conditions vary, the coil might need to be fired slightly sooner or later. In the old days, advancing the ignition timing was done via mechanical or vacuum controls. You've probably heard of the vacuum advance system used on older cars. But today this timing adjustment is performed electronically by the computer. It will fire the coil sooner based on certain operating conditions, such as high RPM. Many vehicles use a knock sensor as an input to determine if the timing is being advanced too far by the computer. This knock sensor picks up the vibrations from the engine that many of us would call pinging. If it senses excessive pinging, it tells the computer to adjust the ignition timing accordingly. This adjustment is critical to operate the vehicle at maximum efficiency. Now that we understand the components of the OBDII system, let's move on and talk about how to communicate with the system and how to diagnose problems within the system. The system uses a standard connector so that diagnostic information can be obtained from any vehicle using the same diagnostic tool. This tool goes by several names, but most often you'll hear it referred to as a code scanner. This is the tool that you use to obtain the trouble codes from your system. When your check engine light comes on, the computer stores a trouble code in its memory. These trouble codes are read by the scanner, and that is how you begin the process of identifying the source of your check engine light problem. You can also take the car to AutoZone where they can help you determine the trouble code. The vehicle we're working on today is a 2001 Isuzu Rodeo. The check engine light came on, so we know it has at least one problem. To get a better idea of what's going on, the first thing I'll do is connect the code reader to the computer's data connector and retrieve the stored trouble codes in the computer memory.
Get in the zone, AutoZone.
We want to install our scanner onto the OBDII connector of the vehicle. Now, by law on OBDII, the connectors can be located somewhere near the steering column area. It may take a minute or two to find the connector. On this vehicle here, it's right here on the bottom left side of the dash. Another nice feature about OBDII is there's only one way the connector can plug in. Let's go ahead and connect our code reader. Okay, now we have the OBDII scanner connected. Something else to mention, if this was an OBDI vehicle, the diagnostic port could be several different places, including under the hood. With the scanner connected, the next step, we want to go ahead and turn on the ignition. You don't want to start the vehicle, just turn it on. That'll give the scanner a chance to communicate to the onboard computer. Now our first option is to read the codes. That's what we want to do, is read the codes. So we'll press enter. And right now the code reader is linking to the onboard computer. Okay, there's our code, P0342. A P0342 is scrolling at below the code is telling us that we have a problem with our camshaft sensor. Now that we have our codes, we'll go back to our information system and see what steps we need to follow to help determine what the cause of the problem is. The code reader gave us the code numbers P0342. There are several places to find the description for the codes. The first place is your local AutoZone store. They have the code numbers in their system and can look them up very quickly. The next place is the vehicle repair manual. The manual will list each code number and definition. The third place is online. You can use a search engine to search for OBDII trouble codes. Another great electronic source is ALLDATA DIY. We'll talk more about that option in a minute. Now that you have the codes retrieved, you can begin your basic diagnostic procedures to try to isolate the exact problem with your vehicle. A few words of caution though. Retrieving trouble codes is only the first step in a complete and accurate diagnosis of the vehicle's problem. The temptation when you see a trouble code may be to start replacing parts related to the trouble code. For example, some code descriptions may indicate a high or low voltage reading by a certain sensor, like the oxygen sensor or the throttle position sensor. This doesn't automatically mean the sensor is bad. It could be the sensor reading is only a symptom of a different problem. So you have to diagnose the cause, not the symptom. Your vehicle repair manual is a great place to turn to for information during your diagnosis. Many systems are explained in detail in the repair manual. Also, the manual will include wiring diagrams that can be helpful in determining the root cause of your problem. I also want to mention another great source of information, OBDII. OBDII is a company that has been providing diagnostic and repair information to professional shops for many years. And now they're offering vehicle-specific diagnostic and repair information to customers. The website is alldatadiy.com. You can purchase a subscription for your vehicle, and it contains just about all the information you'd find in a repair manual, including wiring diagrams and OBDII code descriptions. AutoZone will also contain good diagnostic techniques to help you track down the root cause of your check engine light. I use AutoZone quite a bit, so I'll show you how it'll help us here today. And finally, if you reach a point where you aren't sure how to proceed in your diagnosis, it's best to stop and take the vehicle to a certified mechanic. Okay, we have our trouble codes retrieved. Now we need to focus on identifying the cause of the problem. The code description on our rodeo tells us that our fault area is the camshaft position sensor. To help us diagnose the cause, we'll turn to AutoZone.
Once you have logged on to the AutoZone system, click on the link for your vehicle, and then click on All Diagnostic Trouble Codes. Now select Codes by Number and find your code. Okay, here's the information that comes up for fault code P0342. At the top of the screen is a wiring diagram, and underneath that you'll find diagnostic aids. The aids are used to cross-reference information that can help you locate the problem faster. For instance, here it is telling us that the camshaft position sensor shares a ground connection with the crankshaft position sensor. So if you also got a fault code for that sensor, there's a good chance that the ground connection is bad. Another cross-reference shows that if the scanner also indicated a fault with a fuel injector, the power supply would be suspect. We didn't have a fault code for either the crankshaft sensor or a fuel injector, so both the ground and power supply are probably okay. The diagnostic tree is further down the page. It's just a list of simple yes or no questions where each answer guides you to another step in the troubleshooting process. By going through the procedure step by step, you can find the cause of the actual problem, which may or may not be the component that the trouble code points to.
Well, we know we have a problem with the camshaft sensor, but before we just actually replace the sensor, there's a couple of things we want to look for. One of the most common problems for setting a code like this is the connections going to the sensor. So that's where we want to start. We want to go ahead and check the wiring harness going to the sensor. Check the plug, make sure none of the terminals are damaged or bent or even pushed out. And also check the terminals on the sensor itself. We want to check the wiring harness going to the sensor, make sure the wires aren't chafed or cut or pinched. So that's our next step. We want to go back to the vehicle and take a good look at the wiring harness going to the sensor.
Be cautious when working under the hood. If the engine has been running, components will be extremely hot, so be careful what you touch. When working around a running engine, it is important to be alert and never wear loose clothing or a necktie that can get tangled in belts, pulleys, or the fan. And always remember to wear your safety glasses.
We're going to check the cam sensor wiring harness on our Isuzu. I've taken the hood off so you can see what we're doing, but that's not required in order to do this procedure. Now what we want to do is check the wiring harness to the camshaft sensor. Now this is one sensor. It's a little bit difficult to get to compared to some of the others. As a matter of fact, there's the wiring harness right here. It goes into the main engine harness, goes across the front cover and goes down. One nice thing about the wiring harness on this Isuzu is it actually has factory disconnects so you can disconnect the wiring harness. But we'll get into that a little bit later. I want to show you something else too. We had mentioned the TP sensor. Now the TP sensor, the wiring harness for that is right here. So it's basically real easy to get to. As a matter of fact, let's unplug it. We'll just take a look at it, and you see there we have a 3-wire sensor. We have the 3 terminals. And this is what we're going to look for. We're going to look for any kind of condensation, any kind of corrosion built up in the sensor. Also, as you can see, this even has a weather seal on the connector to stop moisture from getting in there. You want to make sure those are in place. Let's go ahead and reconnect that. The next thing I want to do is I want to go ahead and take our duct out of the way, the air duct, and that'll allow me to get to the plugs on the other end. And also, once the duct's out of the way, I want to take the top cover off the valve cover here. It's got a plastic cover, so I can get right to that connector for the camshaft sensor. So what I want to do is go ahead and take the duct off here. It just basically unsnaps from our air box. We have our air intake sensor. We'll disconnect that. We've got our hose for our power brake booster. We'll get that out of the way. Okay, go ahead and take the air hose off. And also take our clamp off the throttle body. Well, now that we have the air duct out of the way, one thing you want to do with the throttle body being open, let's go ahead and put a rag over that so nothing accidentally falls in there. Okay, now you can get a better look at our wiring harness. The next thing we'll do is go ahead and take off the top cover. With this top cover off, it also gives us access to our spark plugs and spark plug wires. So if you're going to tune this engine up, you would take this off. Now there's no gasket or seal on this. It just basically sits over as a shield over the spark plug wires. Okay, now here we are. There's our 4 plug wires, and there's our camshaft sensor right down here. Okay, so what I want to do is disconnect the plug. This has got a spring clip that's actually locking the plug onto the sensor so it can't accidentally come off. And that's one thing we want to look for, is to make sure it is snapped on all the way, which it is. Next thing we'll do is go ahead and depress our spring clip. It's like a little wire, and pull it straight up. There we are. Okay, there's the connector for the camshaft sensor. This is a 3-wire sensor, so it's going to have ground, voltage, and then the return, or the sensor wire to the computer. Now this is one end of the harness right here where it's going on to our sensor. What I want to look for is any kind of corrosion inside of the sensor. Now one way to determine if you have corrosion or not is it'll be like a greenish tint to it. Something else to keep in mind, like we're talking about on the TP sensor, there's the rubber seal. If you look inside there, you can see like an orangish color seal. You want to make sure that's in place. That stops moisture from getting into that connection. With my sensor being exposed now, same thing there. I want to look at my terminals, make sure none of them are bent. Sometimes you'll actually see a terminal will be broken off, so there's no way that it's going to work correctly. With this disconnected, my wiring harness goes across the front over here and over here to these 3 plugs. Now what I want to do next is go ahead and take my power steering reservoir out of the way. Then I can go and disconnect these 3 plugs. This is really nice because it does have this breakout feature, because what I can do, I can go to our cam sensor connector and actually probe one terminal of the cam sensor connector with an ohm meter and come over here to our plugs and probe that connection here, and that'll tell me if there's any resistance in the wire. Now why is that important? Because the engine's mounted in rubber and the wiring harness is pretty much fixed to the engine. That means it's stationary. But there's a loop down there where the harness goes from the engine to the body of the vehicle. In that loop, there's a good chance that that could be broken. So this test that we're about ready to do will determine whether or not we have a problem with the wiring harness from the connectors to our sensor. Okay, there's our 3 wiring harness connectors. This is the engine side of the harness, and that's where we want to do our test. So what I want to do, take our DVOM again, put it on ohms scale, and we're not going to read voltage, we're actually going to read continuity. That's going to tell us whether or not we have a break in our wire or any resistance in the wire. So we take one end of the DVOM and we'll probe this terminal. You want to be careful you don't damage the terminal when you probe it, because then we'll create a new problem. All right, we've got one end connected, and you can see right now we're showing an open circuit because basically it is. We have the other end not connected to anything. Now this is where the AutoZone came in handy. It told me that on this green plug here, and I'm looking at this, and I'm looking for a blue wire. As a matter of fact, that would be my wire right there. It's right next to this yellow wire. So what I want to do, I want to go to the terminal side of the connector, and I'm just going to touch that, probe that, and if you look at our meter, we're showing 0 resistance in this wire, so this wire is in good condition. Now this is from this terminal to the terminal on the camshaft sensor. I'm going to do the same thing with the other 2 terminals. So the same thing, I'll probe the second terminal. Be careful not to bend the terminal, there we go. And we'll come over to our harness. Okay, if we turn our connector over, we've got the blue, we've already checked that connection, the yellow, and now we've got the red wire. That is the wire we want to check. So the same thing, we go inside of our connector body and just touch that terminal. And again, we have no resistance at all in that connection, so that circuit is also good. Okay, our final circuit, okay, this is our third and final connection. We've got it probed. And now we skipped colors of plugs. The first 2 we checked were on the green connector. Now we're going to go to the black connector, and we're looking for a yellow wire. As a matter of fact, it's right next to a black and a yellow. You see the black and yellow, and we have the yellow. It should be this connection right here. So the same thing. We touch the terminal of the connector, and there we are. Okay, all 3 circuits coming out to the camshaft sensor are good. Now this is from this connection to our plug connection. Now the wiring harness going to the processor or the computer would be checked basically the same way. You'd go to the connectors, the female connectors out here, and onto the processor plug. Well, the wiring to the processor, the computer inside, everything in there checks out fine. So basically, I don't have a problem in the wiring harness at this time. The next thing to do now is to put all of the connectors back together, basically reassemble the engine compartment, and then I want to go back inside and I want to go ahead and clear the fault codes. And there we have it. You know, the thing is, so far we really haven't found anything that caused our code to set on this. But there's a good chance, just with our testing here, just disconnecting the connectors and putting the connectors back in, that may have even corrected our problem, as odd as that may sound. The thing to do now is we'll clear the codes, and if the light should return back on and we check it and that same code appears, then we'll have to go back into this again. If that would happen, I would suspect now that we would have a faulty sensor. The thing of it is, you just don't want to go ahead and automatically replace the sensor at this point, especially on a vehicle like this, because basically you're going to do the same thing as you would do to replace the timing belt. And if you do that without knowing for sure that you've got a problem with it, that'd be a waste of your time and also a waste of money. The nice feature of the code reader is it not only reads the codes for us, it can also erase the codes. Let's say that we did find a problem, we repaired it, you'd want to clear the codes. Well, the same thing with the intermittent. We can go ahead and clear the codes, test drive the vehicle, see if the check engine light comes back on. If it does, we can reattach the code reader and find out which codes returned. Let's go ahead and clear the fault codes. To do that's real simple. The same connector we were at before, we reconnect. We want to turn the ignition on, but not start the vehicle. Okay, on our main menu here, we're going to select Erase Codes. We'll press Enter. It's going to link to the onboard computer. It's asking us whether or not we want to erase the codes. So we want to select yes, and it's asking me verify the engine is off and the key is on, and then press enter. Right now it's erasing the fault codes. Okay, the erase is done. We'll press enter. Now we're back to the main menu. The next step is to go ahead and unplug our code reader and test drive the vehicle.
As we've seen, the camshaft position sensor is just one of many that can cause the check engine light to come on. We have a 1995 Ford Explorer with an O2 sensor trouble code that we will take a look at. But first, let's talk about some of the other sensors and what they do.
Well, after the test drive, the check engine light stayed off, and that's telling me that the camshaft sensor is an intermittent fault. What that means is right now the problem's not there. A lot of times if you'd have a defective sensor, you'd have a hard fault code, and what that means is the check engine light would immediately come back on and the trouble code would come back into memory. So the thing to do now is just to keep an eye on it. If the light comes back on, we'll have to go farther into the ALL-data system and troubleshoot and find out where our problem is. You know, the camshaft sensor is one of many input sensors that the computer uses. It uses the sensors and then it commands like an output, for example, like the fuel injection system or the ignition system. If we'd have a bad camshaft sensor, well, for example, here's one right here. Now, if you look at this, it's really pretty basic. This is a magnetic sensor, and the way this works is real simple. Now, this is a two-wire sensor. There's two wires to the sensor itself, but there's a trigger wheel on the camshaft. Either you'd be on a camshaft gear, it could be on the camshaft itself. As that reluctor comes around, it breaks the magnetic field, and that input is sent to the computer so the computer knows where the camshaft is. Now that's relative, for example, like to the fuel system, when to activate the fuel injectors. But the camshaft sensor is one sensor. Another sensor we have, now this is the crankshaft sensor. Now if you look at it, they look totally different in design, but they basically do the exact same thing. The crankshaft sensor even has the bracket that comes with it. This makes it vehicle specific. Now this is a three-wire sensor as opposed to the two-wire sensor. That's where the wiring diagrams in the ALL-data system would come in handy, where to check the different circuits. Now if you look at this, it's also a magnetic sensor. It's not as strong as our camshaft sensor is, but the same thing applies. It's got a reluctor that comes around and it triggers or opens the circuit. Now the information from the crankshaft sensor, for example, would be used for spark to tell it where each one of the different cylinders are in accordance to like the compression stroke where it's going to fire the ignition system. Well, there's the cam and a crankshaft sensor. We have a third sensor. This looks a lot like it as well. It's also a magnetic sensor, but this is a vehicle speed sensor, another two-wire sensor. It's got the mount where it mounts on. This will either be mounted like in the transaxle, the transmission. Sometimes these are even in the instrument cluster. It'll look a little bit different than this. But the same thing applies, and this actually sends a pulse to the computer to let the computer know how fast the vehicle is going. So there's three sensors there, but then we get into a couple of different ones I want to show you. For example, these are both temperature sensors. The computer needs to know what the coolant temperature and also the intake air temperature is. Now, why is that important? Well, in a carbureted car, you'd have the choke system, so whenever the engine's cold, naturally you need more fuel to allow the engine to run. Well, this is a coolant sensor, and if you look at the tip, this would be in the coolant stream, and what it does, it monitors the temperature of the coolant. And when the engine's cold, naturally it needs more fuel, and this is one way that the computer knows where the engine temperature is. As the engine warms up, it needs to have less fuel, and that's where this also comes into play. The incoming air for the engine, if you look at this, this looks a lot like the coolant sensor, except the thermistor on this is actually exposed. It's right there inside this cage. The cage is there to protect the sensor itself. The airstream actually goes past the thermistor and tells the computer what the intake air temperature is. We have another sensor, and this is used on some vehicles. This is a mass airflow sensor. And what this does, all of the incoming air it takes to run the vehicle goes through the sensor. And some of these mass airflow sensors will even actually have the intake air sensor will be combined in it. But if you look at this, as the air flows through that, there's even a screen on the back side of this. There's a thermistor inside there that actually tell the computer what the airflow rate is. This is very important for the fuel injection. A lot of times with this sensor here, it's something else you'd want to check if you had trouble code for this sensor would be the air ducting going to it, because if you had a crack in the air ducting, naturally the airflow rate is going to be different. Two of the most common sensors that you're going to find and have a problem with, one is going to be the O2 sensor or the oxygen sensor. The reason for that is the O2 sensor, the tip of it, actually goes into the exhaust stream. So like when you take out a spark plug and you look at the tip of the spark plug, after a period of time, naturally it's going to be worn, it's going to have some debris on the tip of it. The same thing applies to the O2 sensor since it is in the exhaust stream. Now the O2 sensor is kind of a unique sensor because it has the capability of creating its own voltage. What its job is to monitor the amount of oxygen in the exhaust system. If there's a lot of oxygen, it tells the computer that the engine is running too lean. If it has less oxygen, it's running too rich. So the computer is constantly monitoring this. This is a fuel control device. Now, if you look at this, a couple of the variances on a sensor, as you can see, this sensor here is a 4-wire sensor. This has a built-in heater element in it. What that means is the oxygen sensor will actually be preheated through a built-in heater. The reason that's important is this is going to be an inaccurate reading until it gets up to operating temperature. Another sensor we have to show you here, this is called a TP or a throttle position sensor, and this is a very important sensor, and these have a lot of problems because it is in fact a mechanical sensor. This actually hooks to the throttle shaft. Now the screwdriver would represent the throttle shaft, either on the carburetor or on the fuel injection unit, and it's constantly rotating. There's a resistor inside of here, and as this rotates, it actually sweeps past that resistor, and that value is sent to the computer to basically let the computer know where the throttle angle is. Now, why is this important? Well, it'll tell the computer when the engine is at idle. For example, like on a carburetor, you have the accelerator pump that would bring a light from one circuit to the next. That's all done automatically with a TP sensor. It would be a smooth transition to like the voltage at idle to the voltage on wide open throttle. And this is really easy to check off of the car. Let me show you how to do that. Basically, all we really need is a digital volt ohm meter, and we're going to use the ohm circuit. And what we want to do is just actually check the resistance of the sensor itself. Let me get this set up here, and then I'll show you what I'm doing. Now, this is a 3-wire sensor, and what that basically is, it's going to have voltage, ground, and then the signal return from the sensor. Now, you've got a 12-volt system in your vehicle, but something unique about this sensor, and some of the others is it'll use like a 5-volt signal to this. So it's not a 12-volt sensor. You have to be very careful when you're testing these, especially if you're using what type of equipment you're using. You wouldn't want to apply 12 volt to it, so you'll instantly damage the sensor. So I've got the 2 leads hooked up to it. We'll connect them to our DVOM. There we are. Make sure everything's separated. We'll put this on our ohm scale. And what I want to do, I want to just basically take the screwdriver, put it in where the shaft's going to go, and I want to watch my DVOM as I turn the TP sensor. Now what I'm looking for is a smooth transition from all the way at idle to wide open throttle. And I'll tell you what, this sensor here has got a bad spot right off idle, about right there. And what you'll see on the DVOM, you'll actually see where the ohm reading will go open, like an open circuit. And that's what you want to look for. Now what this will do is, if you've ever had a problem with a TP sensor, what it'll do is you'll have like a flat spot and almost like a bad accelerator pump on a carburetor. So like you're at idle right there, and as soon as you touch the idle and get off idle, that's where this is open right there. So what that would do is, at that instant, the computer doesn't know where the throttle angle is. So it has to try to compensate for this sensor. And then the bad thing about a TP sensor, it'll give you multiple kind of performance issues, because once you get past that point, like right there, then all the way up the rest of the way, it's fine. So just that one spot right there. Now, this is the kind of things you want to look for. Now, the way to know whether or not you have a problem with the TP sensor, this is where the trouble codes comes back into play. If you have a fault code for a sensor, there's a couple of different easy ways to check this, and then there's the most common problems, like, for example, this would be the sensor itself. Well, like the TP sensor, like I mentioned, the O2 sensor is another common problem. Now, the thing of it is if you have an O2 sensor code, just don't automatically replace the sensor. There's other things that can cause the code to appear. This is not a real inexpensive item. Something else to keep in mind is some vehicles can have up to 6 O2 sensors on it. The front ones are going to take care of the fuel control, but then you have the others in line. We have a vehicle here that does have an O2 sensor code stored in its memory, so let's go check it out. Well, the next vehicle we want to talk about, we have a 95 Ford Explorer. It has a 4.0 V6 engine in it. The check engine light is on this vehicle as well. Now, the thing of it is, the check engine light on this is showing us a lean O2 sensor code. And what I want to do, this is a perfect opportunity to show you a couple of simple tests that you can make to determine whether or not you have a problem with the O2 sensor, or if you have a problem with some of the ignition systems or fuel systems on this vehicle. Now, to do that's pretty simple. This has a multi-port V6 engine. What that means is there's an individual injector for each cylinder. I want to show you how you can check the circuit to the injector, and also you can just listen to the injector, tell whether or not it's working. Another test I want to do too is I'm going to take and show you how to install a spark tester to check to make sure you do have adequate spark going to the spark plugs. One of the final things we'll do is I want to show you how to do a visual inspection. For example, we have the vacuum routing diagram on this vehicle. I want to check there's about 4 different vacuum hoses. Take a good look at those to make sure the hoses are okay. One other thing I want to do, the last test is, and this is pretty important too, is show you how to do a fuel pressure test the correct way and what you're looking for. So let's get started. The first thing I want to do is I want to go ahead and check our fuel injection system. Now what they have available, and this is part of the AutoZone Loan and Tool program, this is kind of a unique little tool. These are called Noid lights. Now if you look at these are little LED lights. They have different pin configurations determining what type of vehicle that you're going to use it on. Basically what you do is you can unplug the connector on the fuel injector. The Noid light's going to plug in that connector. You can start the engine up and see if the Noid light flashes. If the Noid light flashes, that tells you that you're getting good power and ground going to the injector. So what we want to do, we want to do this test first. We'll unplug one of the fuel injectors, install the Noid light, and see how this works. Okay, there's our fuel injector plug. I've got the center injector is unplugged now. But what I want to do, okay, we want to see which Noid light terminals are going to match the terminals on our connector. And I think that's it right there. It is. And that's what it'll look like when it's installed properly. It'll just seat down into the connector. Now, the actual bulb is right up here. So our next step now is to go ahead and start the engine up and check to make sure the Noid light flashes. Now something else I want to mention too is I've also removed the hood on this like I did on the Isuzu, so you can get a good look at this. That isn't required for the repair. I wanted to just double check around everything, make sure everything's clear. Let's go ahead and start the engine up. Okay, yeah, there's the Noid light working. If you look at this, we've got a flashing light. So that tells me that the power and ground going to the injector is working. Something else to notice too, you can see how the engine has kind of a rough idle right now because I basically have killed that one cylinder by disconnecting the fuel injector. So now I'm going to shut the engine back off and connect this back together. Okay, we can go ahead and disconnect our Noid light and plug our connector back in for the fuel injector. Now we've got the lean fuel code for the O2 sensor. Now one good cause of that could be low fuel pressure. Right next to the injector that we just checked with the Noid light, there's a tap port for the fuel pressure system. Yeah, a lot of vehicles are going to have this test port. You just look into your information system, it'll tell you where it's located at. If it doesn't have one, there's specific adapters you can do to hook a fuel pressure tester to the system. But what I want to do, here's a fuel pressure gauge, and this is available through AutoZone. What you can do is you can go ahead and attach the gauge to the fuel rail and start it up, and it'll show us our fuel pressure. Now on the Ford application, it requires one adapter. Basically the standard size that's on the gauge hose, this makes it a smaller size to fit our port. So the first thing I'll do is I want to put the adapter onto the port. Before I do that though, I've just had the engine running, so there's going to be some fuel pressure in this rail. I want to put a shop rag around there to catch the leaking fuel, and then we can go ahead and install our tool. Now we can install the adapter. And now our fuel pressure gauge hose. Okay, we've got that snug. Now we want to make sure that the fuel pressure gauge is out of the belt system while the engine's running. So what I want to do is just kind of put this right over our area. I'm going to leave that shop rag in place in case I would have a leak, because as soon as the engine starts, that's the first thing I'm going to do is check to make sure I don't have a leak at my fitting. Okay, let's start the engine back up again. Okay, our fuel pressure is in spec. It took just a minute to bleed the air out of the system. But as you can see, if this would have been, the fuel pressure would have been low, the next thing you would have wanted to check for would be the fuel pressure regulator, and then finally, we could have a problem with the in-tank fuel pump. In our case, we're fine. So next one, we're going to shut the engine off and take our fuel pressure tester off. Now the fuel pressure tester actually has a release button right here on the side that's going to release the fuel out of this hose. That way when I disconnect the hose, it's not going to spray all over. Something else that's kind of a neat feature too is that if you did have low fuel pressure, you can actually check and see what the volume of your fuel would be by holding the button in and catching it in a container. Let's go ahead and release the pressure. Okay, let's go ahead and take our fuel pressure tester off. And our adapter. There we are. One of the tests we want to do with the fuel system, the fuel injectors, we've already checked the circuit to the injector with the Noid light, and we know the circuit is okay. But there's a neat trick you can do here. It's real easy to do with a mechanic stethoscope, just a standard mechanic stethoscope. These are available at AutoZone. You can actually listen to how the injectors are working. What I mean by that is the fuel injectors are basically a 12-volt solenoid. The more ground the computer gives the injector, the farther the injector is going to be open. What we want to listen for is an audible click to each one of the injectors while the engine's running. You'll hear like a clicking sound. And so a couple things we want to do here. One is we want to make sure that the injector does click. For example, the injector we just tested, if the Noid light showed the circuit was good, but yet there was no click from the injector, we know the injector is dead and would need to be replaced. Something else we want to do is we want to check all 6 injectors and listen for the click. It should have a nice crisp click to it. If it doesn't, for example, if you have 2 or 3 injectors that have more of a dull sound to it, you know those injectors are dirty. In that case, the repair would be to add fuel injector cleaner to the fuel tank, and after a little bit of drive time, come back and listen to the injectors again and see if the problem's solved. So what I want to do now is start the engine back up. With a stethoscope, I want to go around and listen to all the injectors and see how they sound. Now when you're performing this test, a couple things to keep in mind. One is the engine is running, so make sure you stay away from the belt area and the alternator area. What I'm going to do is I'm going to place the tip of the stethoscope on each one of the injectors, and I'm going to listen to the click. Now some of the injectors are easy to get to, and some of them I'll actually have to go through the passageways here by the intake manifold. This is just going to vary from vehicle to vehicle, but the main thing is just be conscious of the fact that the engine is running. Let's go ahead and start with the very first one. And what you want to do is place the tip of the stethoscope right on the body of the injector, like right now. I'm listening to the number 1. It has a good crisp click to it. Let's go to number 2. Okay, now the first and second injectors sound exactly the same, or close to it. Number 3 in row here. Now this one, it's working, it's operating, but it doesn't have that crisp sound that the front two do. Okay, let's go to the other side. Okay, that one sounds good. That sounds like the first two I checked. Let's see if I can get on that one. Here it is. Okay, and that has a crisp click to it as well. Now let's go to my last one here. Okay, that one sounds good. Okay, all 6 injectors are working properly, except the very last one. I'd be concerned with the fact that it is a little bit dirty. The next step really that I would advise in this case would be to go ahead and put the cleaner in the tank, drive it a week or so, and listen to them again to see if that improves that one injector. Let me go ahead and shut the engine off. Well, so far we know we have the one dirty injector, so adding the cleaner to the fuel tank is going to definitely help. But what I want to do next is I want to talk about the ignition system. Now, it seems like the newer the vehicle is, the more advanced the ignition systems have become. On our 95 Explorer, what we have here is a DIS, or distributed ignition system. That's pretty common. This one here uses one coil pack with all 6 cylinders on it. Now, when you go to check for a spark, I mean, it used to be you could just take the spark plug wire off the cylinder and just watch to see if you had any arc from it, but you don't want to do that, especially on the newer vehicles. The extreme high voltage and the amperage that these are capable of producing could actually seriously hurt you or even cause death, so you don't want to actually touch it while it's running. Instead, there's a system you can put on this. This is kind of a unique little system. This is a spark tester, and what this is going to do, this is going to go in line between the spark plug wire and the spark plug. As the engine is running, you're actually going to see the light inside of the tester flash each time spark is sent to the spark plug. So what we want to do next is go ahead and install this. It's pretty simple to install it. We just disconnect the spark plug wire from the spark plug and install this in between the wire and the plug. Okay, there we are. Now there's our plug wire. As you can see, we're on the coil pack. Here's all the way to the end of it. Something else is a good time to go ahead and just check for corrosion inside of the tip of the wire. If you see any corrosion there, the wire needs to be replaced. With this off, we just take our tester and plug it into the wire. The other end just plugs onto the spark plug. And there we are, we're connected. Now, the nice thing about this is it actually gives us a window into the working system so we can tell and see if everything's working properly. Let's go ahead and start it back up again. Okay, you can tell by our light in our tester that we've got a good, crisp spark. Everything looks fine. Something else to watch, you just don't want to watch for the light to flash. You kind of want to watch the light flash in time. If you notice like a skip in it, like for example, it'll flash, then maybe a pause, then flash, then maybe a pause, that's a good indication that you either have a faulty spark plug wire or even a defective ignition coil. If you had no spark at all, the next thing to do would be just, you want to check each one of the wires individually to see if this is the only cylinder that's affected or if you've got multiple cylinders that have no spark. That could be a faulty coil pack or even have a problem with a crankshaft sensor. The next thing to do is go ahead and shut it off and we'll hook the wire back up. Let's go ahead and remove our spark tester. Well, so far we've covered a lot of tests, and if you look at it, none of this has really been hard to do or it required real expensive equipment. There we are. Okay, the next test I want to run on this is more or less just a visual inspection more than anything else. Now, if you look at this, our emission decal under the hood, and every vehicle should have this. It'll show the routing diagram for the vacuum hoses, and it seems like the older the vehicle is, the more vacuum hoses they'll be equipped with. There'll be 30 or 40 hoses in some cases. The newer the vehicle is, the less vacuum hoses are required. Like in our case here, we basically have about 5 or 6 hoses and that's it. And they're not even really hoses. Most of them are nylon lines with rubber tips where they connect onto the devices. Now, the reason a vacuum leak is so important, especially like in our case, we have a lean problem here. Well, if the vacuum hose was broken or off, that's going to allow additional air to enter into the engine, and that would cause our lean condition. So what I want to do is I basically just do a visual inspection. I know where they're routed. I just want to check around, make sure they're connected, make sure I don't have any broken lines. And that's it. I'm done. They look fine. As a matter of fact, what you want to do is you want to check to make sure that they're not brittle. During the test, just by checking them, a lot of times you can actually break one. And if you do, that's really kind of a good thing, because if it's that brittle that if it breaks when you touch it, you know it's going to break as the engine's running. But in our case, all the nylon lines are still flexible. They're all attached. So everything looks good. Well, on this vehicle, we know that we have one injector that's dirty, and that may be causing all of our problem, our lean condition. So the step now is to go ahead and put the fuel injector cleaner in the fuel tank. We're going to go ahead and drive the vehicle, but there's still a chance we do have a bad O2 sensor. But we need to know for a fact that we have a problem here, so we want to correct this problem first and then go back and see if the code reappears. Well, that takes care of this vehicle here. Next, I want to pull in another vehicle that has kind of a unique ignition system on it. It's called a coil-on plug or a COP ignition system. We're going to pull that vehicle in, and I'll show you some simple tests to do on that. And we've got a 2001 Chrysler M. Now this is a good example of the coil-on plug system. V6 engine. And the coil-on plug, you can see it here. We've got an individual coil for each cylinder. Now this is really a nice system. It's probably the most accurate ignition system out there. Basically what it is the ignition coil, the spark plug wire, all combined into one unit. Now these are fairly easy to check. Now when you'd want to check this, if your check engine light comes on, and we mentioned about the check engine light flashing. Whenever you see the check engine light flashing, you could cause extreme damage to the emission system like the catalytic converter. And one of the main causes of that is a misfire. This would be a cause of a misfire. Now to check this is real simple. Basically, we have the electrical connector to each one of the coils. So we're just going to pick this one for example. Just go ahead and disconnect the connector. The end of the connector looks an awful lot like that fuel injector we just checked. As a matter of fact, the Noid light set that we used on our fuel injection system, we can actually use it on our coil-on plug system. So what we want to do is find the Noid light that'll fit into the terminals. And just like on our fuel injector, we take the Noid light and we install it into the terminal. So that would be fully installed. Now the next step is to start the engine, and we want to watch the Noid light just like the injector to make sure it flashes. Okay, you can tell by looking at the Noid light that the light is flashing, so that means we do have power and ground going to the coil. Let's go ahead and shut the engine back off. So for example, if we had a misfire, this is number 2 cylinder. If we had a misfire on number 2 cylinder, this would be our first step. We want to check for voltage and ground going into the coil, and the Noid light's the safest way to do that without damaging the computer. The next step we can do, let's go ahead and remove the coil-on plug assembly. It's held in place with 2 Torx screws. And there's the coil-on plug unit. There are the 2 terminals that the plug plugs into. Now there's another test we can do on this. Now if you look at this, this is basically the spark plug wire. The difference between this and a regular set of spark plug wires though, if you bought all 6 coil-on plug units, that'd be very expensive. So you want to make sure that you would have a faulty unit before you replace it. Another test we're going to do using our spark tester again, And this time with an adapter. Now if you look at the adapter, there's a long reach going from the coil on plug unit down to the spark plug. That's where the adapter is going to come into play. Basically, we're going to put the adapter into the hole, click it onto our spark plug, and then we can install the spark tester. One end goes into the adapter, and the other end is going to go into our coil on plug unit. With that in place, we go ahead and reconnect our connector. Just like that. Let's start the engine again. What we want to watch for is we want to watch for a flash on our spark tester. Now one thing to keep in mind, we do have the two mounting screws that mount the coil on plug to the engine. Now this is an insulated circuit, the coil itself is, and we have our power and ground on our plug. So the mounting of this, there's no need to ground the unit. Let's go ahead and start it back up again. What we should be looking for, you'll see the flash on our light if the coil on plug unit is working. Okay, this is one real simple test to tell whether or not you have a functioning unit. In our case, we do. So this coil on plug unit is good. Okay, if our NOID light would have flashed but we would have had no spark on our tester, that would confirm that you had a faulty coil on plug unit. Basically what you do is do all 6 the same way, or if you have a specific cylinder that the trouble code is going to point you to, just do the test on that one cylinder. Let's go ahead and reinstall our coil on plug unit. The fuel injection test that we performed, along with both of the ignition system tests that we performed, are going to pretty much take care of most of the misfire codes that you run across. These are the steps to follow when your check engine light comes on. First, retrieve the trouble codes with an OBDII scanner. If you don't have a scanner, the folks down at AutoZone can pull codes for you. Next, consult your repair manual or all data system to determine the description of the code. Again, AutoZone has these codes in their system if you don't have a repair manual handy. After you've determined the trouble code, consult your all data information for troubleshooting steps and techniques to help isolate the root cause of the problem. Remember the tests we have shown you today for your ignition system, the fuel system, and your wiring harnesses. After you've made your diagnosis and repair, reset the trouble codes on your vehicle and test drive it to make sure the light stays off. Finally, remember that if at any point of your diagnosis you're not sure how to proceed, you should stop and take your vehicle to a certified mechanic. Replacing parts when you're not sure the root cause can be very expensive and time-consuming. Well, I hope this video takes the mystery out of your check engine light diagnosis. The next time your check engine light comes on, you're going to know what to do. Thanks for watching. I'm Bruce Bonebrake.
Get in the zone, AutoZone.